It should just be open access. Well, say once, like it's a really, yeah, that's like, I don't know, like,
Okay, guys, we're gonna go ahead and get started. Folks at home, can you hear me okay?
Yes.
Anybody at home?
Yes, we can hear you good.
Great, thanks, Court. All right, welcome back. How many of you attended CypherCon last, Thursday, Friday? Tell us about it. How did it go?
It was awesome. That was great. A lot of good companies there giving away a lot of free stuff.
A lot of swag.
Yeah.
Okay.
For some reason, socks were super popular.
Okay.
I got like 5 pairs of socks from different cybersecurity companies.
So with their logos on them or just
Yeah.
like Star Wars, Star Trekky kind of thing?
No, it was like all the logos.
Okay. Any companies that came to mind that really impressed you or dazzled you?
Like CrowdStrike, like the big top dogs are cool.
Thickitch, were they there?
Who?
Thickitch?
I didn't think they were there.
No, okay.
I learned how to pick a handcuff with a bobby pin.
Okay, so they had some good, okay, so we feel like we've become better hackers, huh?
Yeah.
All right, remember, use for good, not evil, right? That's the goal, that's the goal.
Lots of good keynotes.
Okay, good. Yeah, was it all day Thursday and Friday?
Thursday was 1 till 10 and Friday was 10 to 5.
10 to 5.
Okay, so a lot of,
4 because 5 was closing ceremonies and
Yeah.
everybody started packing up, going home.
couple of keynotes and a whole ton of breakout sessions, huh? Okay, good. And the venue was good?
Yeah.
Good, all right, awesome.
Um,
So let me share my screen here. You all should have received an announcement through IT program students. Canvas. I guess membership in that particular quote unquote class. But just a reminder for those that either skimmed over it or haven't actually seen this. The Hone Bridge, you may be aware of the fact that the Hone Bridge down in the Milwaukee skyline there, they lit it up a handful of years ago, and they're looking for people to assist them with coding whatever light show or shows they're going to be doing. So apparently you don't need any IT experience whatsoever. They're just looking for motivated, interested parties. So check the IT program students Canvas page for the general information session, which is coming up in a couple of weeks. And there's a sign up as well that you can find there. And if you have questions, you can contact Allie, our associate dean, regardless. Okay, so might be a good thing to take part in, right? At the very least, maybe establish some connections and do that human networking that's also important in any discipline that you're in, right? So, and if nothing else, a good thing to toss on your resume, right? That you assisted with that, right? It shows some initiative, I think. Okay, I want to remind everybody that you guys should be checking your WCTC email on a regular basis, and by regular, I think daily is not too much to ask. I'm a father of a 21 and an 18-year-old, both boys that for whatever reason kind of fight the whole email thing. And I tell them, yeah, I get it, right? You guys are into, you know, your generation, whatever, you know, whether it's texting, Snapchat, Discord, Instagram, whatever social media venue you'd like to use, right? But the people that are going to be hiring you, a lot of them, my generation, are going to rely heavily on email, right? So my generation kind of helped to usher in a lot of technology. So we're no strangers to technology. A lot in my generation are, but those of us in the know, especially those of us working in IT aren't, right? So get in the habit of checking your email on a more regular basis, let's just say that, right? And if nothing else, start forwarding any of your WCTC emails to the email that you do check on a more regular basis, right? So get that figured out and squared away so you're not missing out on communications from instructors and really the college overall. With that said, you'll also want to be getting in the habit of, or not even getting in the habit, but what I want you all to do is, if you click on your account here in Canvas, right, and go to notifications, you can get pretty granular with this. But I would not even encourage, I would beg you to set notifications so that you are being made aware of exactly what's going on when it comes to due dates and announcements and that kind of stuff. Right. And I know you can get this all set up in like a daily digest, so you don't have to get it all real time, but kind of defeats the purpose, right? Because if there is a real-time event that the college is trying to get through to you, like, hey, campus is closed, right? You know, there's a blizzard or something that you wouldn't be aware of, like God forbid a school shooting or something, right? I mean, you want to be aware of this and not rely on that digest at the end of the day that gives you a summary of all those notifications, right? So you can do these things for your entire account through this pull down menu, or you can do them per Canvas quote unquote course that you're in. So that would apply to the actual classes that you're in, as well as things like the, you know, the IT student club and whatnot, right? So make sure to get a handle on that, because we're finding that a lot of students are not getting the information that we're blasting out to them in a timely manner, right? You got to be a bit proactive with this stuff, right? You can't just wait for things to happen. Okay, a reminder that the IT Career Day is going to be coming up in 2 weeks from tomorrow. All right, so April 19th, it's a Wednesday. There's a variety of things going on there, be it guest speakers or help with resumes, which will happen prior to that. So again, keep up to speed with what's going on in that IT club, monitor your emails, right? So you're ready for that, right? And I'd highly recommend that you take part in that, right? Again, you guys are here to ultimately land a job. I think that's why you're here, right? I mean, maybe you're a trust fund baby and you've got millions stashed away and you're like, I have nothing else to do, so I'm going to take a class at WCTC and become a hacker. Well, that's fine too, I guess. But I'm betting the vast majority of you don't have that, right? So that being the case, yeah, it's all about networking, human networking, right? So if you have nothing preventing you from joining on that career day on the 19th of April, please join us here. So yeah, better.
IT Club is looking for volunteers to help set up for the actual career fair. So when all the employers are coming in with all their stuff, they just need people to like show them where to go. They'll all be in here or just help them carry stuff. It's also prime time networking, and you actually get to talk to them, be the first one to see them coming in. I think you can email Bradley Wooten if you got any questions.
That's awesome. So email Bradley if you want to volunteer for that. Fantastic. Yeah. Right. I mean, think bigger picture, right? I think too often, and I guess I fell in this trap a bit when I was going for my undergrad. You know, you get caught up in this. I'm just going to go to class and get the best grade I can. Yeah, I'm not trying to discount that, but I think it's important to look at the bigger picture and the stuff you're doing outside of the classroom. Well, for some of you, that could be taking part with the CCDC meetings every Friday, right? It might be stepping up, you know, when Bennett says, hey, we're looking for volunteers, you know, step up and put yourself out there, right? I mean, soft skills, right? I mean, that's going to get you much further in life. We all know people that maybe even struggled academically in school. I know a lot of them, right? They didn't do very good, and guys had one since high school and college. Right, they barely got by, but they had a personality that was fantastic, and they're killing it. Right, they're doing really well for themselves. Right, so again, I'm not trying to discount the importance of getting the best grade point average you can. Right, that's important, but to really set yourself apart from, you know, the other candidates. Yeah, soft skills are going to be critically important. Okay, so let's take a look at our. That was me on my soapbox, by the way. So. Let's take a look at our announcement from last week. Bit tongue in cheek here, you managed to survive, right? Last week's introductory session. So this is, of course, an 8-week course. We moved through things rather quickly. And it's critically important that you do the things I ask you to do ahead of time. So I thought about, kind of asking, okay, who actually read modules 1 through 4? But I don't want to deal with getting responses that are not truthful. And I'll tell you why that's the case. One of the things we can see as instructors is we can see when students last logged on to Canvas. We can see the activity, not super granular, but the amount of time spent. And so when I see some students spent like literally 3, 4, 5, 6 hours on stuff, and others haven't logged in since last Tuesday, I kind of know who did the work and who did it, right? So I'm not about calling people out, right? I mean, that's not what I'm going to do. I'm not going to say, okay, you, and you guys didn't do anything since last week, right? What I want to do though is let you know that we can see this as instructors. We know who's putting the time in and who isn't, right? And where that's going to impact you the most, at least in my opinion, is when I get a student that reaches out and says, hey, yeah, can you serve as a reference for me, Todd? Which I'm happy to do if the shoe fits, right? But if I get a request from a student and they're not putting the time in, I might go, well, you know what? I don't think you were really taking this that seriously, right? So, I mean, again, this is bigger picture stuff, right? And I hate having the come to Jesus talk like I feel like I'm kind of having, but if I put something out there, yeah, read modules 1 through 4, it's not for my benefit. Well, no, I lied, it kind of is, because then I don't have to go ahead and field like ridiculous questions today, like, Todd, what does VLAN stand for? Because you should have read that, right? So, I want to make this as efficient as possible, but I'm really passionate about IT. And I like to think that comes through when I teach. I feel pretty passionate about getting this information through to everybody, right? Because this is really important stuff. Even though you don't maybe believe it or see it now, you will do what so many students that I've had over the last 30 years of my teaching, say to me when I see them on the street, and that's happened before, or when they reach out to me on LinkedIn and tell me what they're doing and where they're working, and hey, thanks so much. And I'm really using this every day, Todd. I'm building VLANs all the time, right? So, I mean, this stuff is applicable and you all need to know this stuff. Even if you're not going to be a network or system administrator, but you're going to be a cyber security professional protecting networks that consist, of course, of VLANs, because they're everywhere, right? So, off my soapbox in a moment. If I put out there just to read, and I was hesitant last week to go, all right, so there's no real actual homework as far as exams and packet tracers, right? Because then students hear that and they kind of shut down and they go, awesome, I get a 2-week vacation, right? So, do what I'm asking here. It's for your benefit. Because now when I go through and I demo stuff and I lecture on modules 3 and 4, you're listening and going, oh yeah, okay, yeah, I remember reading about that. And I was a little sketchy on that, but Todd just clarified it for me, right? Because if you haven't read, and I know a handful of you haven't at all, unless you purchased the hard copies of the books and you read it, so I didn't see it in Canvas there, right? So if you haven't read it all, you're coming into this completely cold, right? Which defeats the purpose of why I say read those modules, right? I feel like a freaking, I'm in dad mode right now, I hate being in dad mode with my students, I get enough dad mode with my own 2 boys, right? So, all right. So, just a reminder, make sure you're using the latest version of Packet Tracer. And I highly recommend, again, investing in this book at some point in time. Doesn't necessarily have to be the latest edition. If you find a better deal on maybe 4th, 3rd would even be fine, probably edition. I also highly recommend you consider down the road, even though it'd be a ways down the road, enrolling in Cisco 3. Right? And I say a ways down the road because that class is only offered once a year in the spring. It's going on right now. It happened last night, so it's Monday nights, usually the second half of spring. But who knows? Maybe at that point you're working somewhere, you get your company to pay for that class. That's kind of the goal a lot of times too. So yeah.
What's all covered in number 3?
So great question. So the question from Bennett was what's covered in Cisco 3? About half of the class is on dynamic routing protocols. And so we're talking OSPF, which is more vendor neutral, and Cisco's EIGRP, it's an interior gateway routing protocol. So essentially, when routers have to share routing tables, how do they do it? Right. So dynamic routing protocols probably comprises upwards of 40% of that class, I would bet. I will get into that a bit the very end of this class because our last 3 chapters are on routing. And this class doesn't really get into dynamic routing protocols, but when I teach those last 3 routing chapters, I think it's very valuable so that you know kind of an idea what they're all about without just focusing on static routing. So one thing is dynamic routing protocols, a lot on WAN connectivity, right? Wide area networking, and a lot on automation using things like Chef and Puppet and Ansible and web dev type of stuff. So it's the only instance that our network students get an opportunity to really kind of delve into the web dev type of world, right? And kind of put on your pseudo programming hat, right? So the name of the class, I call it Cisco 3, but it's just like this class, I call it Cisco 2, but it's got that lengthy, switching, routing, and wireless essentials. Cisco 3 is really the enterprise, so we're looking at larger network infrastructures. It's enterprise networking, security, so we get more into security and automation. Right? And from a cybersecurity perspective, which I know most of you are cybersecurity students, probably the most valuable aspect of that class is going to be getting into access control lists or ACLs, right? Essentially kind of firewall rules, allowing or disallowing certain types of traffic across router interfaces, right? So it kind of runs the gamut. It's a great class. I wish we could make it a required class for our networking students. We just don't have room in our program, so it remains as we don't call it an elective, but it's kind of an elective. Okay. If you guys are interested in taking that class, in any class for that matter, it's not a bad idea to reach out to Allie and let her know. And the reason I say that, and I think I spoke about this last week, is if Allie is not aware of how many people are interested in a class like Cisco 3, she's going to do the same old and offer it probably the second half of spring, every spring beat, right? But if she's got, a list of a dozen students that go, hey, I really want that class, Allie, I don't want to wait till next spring, she might be able to go ahead and offer it up any other time throughout the year. All right. And that goes for any class. All right. So don't just think, oh, I got to wait for it. Reach out to her and go, hey, is there any chance we can get this earlier? And if enough of you do that, that increases the odds of her maybe being able to offer it sooner than later. Okay. All right. You also can talk to her, and there's no promises here, about substituting a class for another. Right? I know that's been the case in the past sometimes. So maybe you're hell-bent on taking Cisco 3. You're like, yeah, what Todd just told me about Cisco 3, that's right in my alley. I think it's going to be a really valuable class. I'm going to go set an appointment with Allie and see if I can't swap out course X with course Y being Cisco 3, right? There's no guarantee there, but she might talk to me and go, hey, Todd, what do you think about this? And I might go, yeah, well, they can't swap out ethical hacking. They need that class, but they're trying to swap out this other class. Yeah, I don't see a problem with that. So it's going to be probably a case-by-case type of thing, right? So kind of a grow your own, roll your own kind of thing. So, okay. So today we are going to be tackling the 2 chapters that I was hoping you had read. I'm not saying you all didn't read it. I know quite a few of you did based upon how much time you've been inside our NetAcad since last week. There. Helps if I use the right password. Okay. Any Brewer fans in the house here? Anybody go to opening day yesterday?
I was working.
You're working.
It was a killer game though.
Yeah, sure was. Yeah. You guys know Mark Ruskowski. Mark and I actually went and just watched it at a bar. We were going to go to the game and tailgate and stuff, but it's a lot of work when just 2 guys are going to throw together grills and bags and all that stuff. So, yeah. Fun game to watch. Oh, yeah, really fun game. Okay, so, we are going to be focusing on modules 3 and 4, and these are the last two modules, as you can see, of this first kind of wave of chapters, right? So the first two modules, quite a bit of review, right? A lot on the basics of switches, right? Layer 2 intermediary devices. What a switch brings to the table, right? We know that a switch replaces its predecessor, the hub, from years ago. And it's a layer 2 device, layer 2 of that 7-layer OSI model, as opposed to the layer 1 hubs, which might have served their purpose of connecting end devices, but not in an intelligent way, right? Remember, years ago, I could take all 24 of the computers in this room and I could connect them to a central hub in this room, right? Visually, that looks like a star, right? The center of this room, there's a hub on a table, and I've got 24 cables coming out of a 24-port hub extending to the network cards in each of these 24 end devices. That's a physical star topology. All the devices could be communicating using Ethernet. Ethernet's been around since the 1970s, right? And they would be communicating through this layer 1 hub perfectly fine, but performance would be horrific, right? Because the minute one device in this room tries to talk to another, right? And how do they talk? Based upon MAC address. How do they find MAC addresses and put them in their ARP cache? They do that ARPing process. They ARP for the IP, hoping to get the MAC back, right? It's like me calling you on the phone using your logical phone number, and you're telling me where you live so I can mail you something, right? That's the ARPing mechanism. So if Lucas is trying to communicate with Daniel through a hub, that's not happening. It's Lucas communicating with everybody through a hub. Daniel responds, hey, you found me, here's my MAC. The rest of you ignore Lucas's request, right? So enter the layer 2 switch. Just a more intelligent hub, that's all it is. Because what do we know about the switch? It maintains that MAC address table, right? It goes into that learning and listening mode, and it ultimately builds the MAC address table so that ultimately when it knows about all 24 devices based on their MAC address, now Lucas tries to communicate with Daniel's machine, it's communicated right there, right? It's a micro-segmented network, highly efficient, to the point where we have 0 collisions whatsoever, and we could have as many as 12 simultaneous connections with 24 devices on the same network, right? So layer 2 switches. That's really what chapters 1 and 2 were all about. Right? It got a bit into, okay, if you've got to troubleshoot and flatten it, put it back to factory defaults, okay, you've got to go ahead and hold that mode button down, right? Get into that low-level switch colon recovery mode, right? You got to reset a password, you got to do that, but you need to have physical access to the switch in order to do those things. Right? Okay, chapters 3 and 4, all about VLANs. VLAN is a virtual local area network. And quite honestly, it simply does away with the need to have devices in the same proximity to each other to be considered part of the same network. Right? So everything we've done up to this point in Cisco 1 and early on now in Cisco 2 is we've looked at networks in the more physical world, right? The physical construct, where devices that are part of the same department, you know, engineering, HR, IT, whatever, are in close proximity to one another. VLANs turns that on its ear, really. It says, you know what, that's not a requirement. We could have devices that are scattered on a campus like this at WCDC, one here in the L building, a couple devices in the A building, a few more way across in the service building in where the gymnasium used to be, right? And they could all be part of the same LAN virtually. Right? They're not connected to the same layer 2 switches, but they don't have to be. The switch here in L, the switch over in A, and that switch over in S, 3 separate physical switches. You know, one device here in L, let's say 3 devices in A, we're talking N devices now, and 5 devices in S, so 9 devices total, connected to 3 different switches that are physically in 3 different buildings, but I want them all to be on the same LAN. That's how we can do some virtual LAN, right? So let's go ahead and do it this way. I'm going to simply come here and we'll go and do this through Packet Tracer. So not a super long lecture today. I want to give you guys a lot of time to start working on that homework assignment and working on some of the packet tracer activities. Right, and a reminder, like I said last week, I will not be lecturing nearly as much in this class as I did in Cisco 1. All right, so again, Cisco 1, we were looking at networks in the more physical world, where we said, all right, yeah, for these guys to be part of the same network, they need to be connected to the same switch. With virtual LANs, we're just going to go with the really simplistic environment here. What I can do is I can configure an environment where PC0 and let's take PC2 over here are part of the same network, while PC1 and PC3, the two bottom end devices, are also part of the same network. And virtual LANs brings that to the table, right? It can be more cost effective because I don't have to dedicate a switch to each LAN, right? It can be much more manageable. I can go ahead and set which traffic is allowed to pass between these switches and which isn't, so which VLAN traffic is allowed to pass. So more cost effective, more efficient. We know about broadcast domains, right? And broadcast traffic. We can isolate those with virtual LANs. So there's a multitude of benefits behind utilizing virtual LANs or VLANs, right? But first and foremost, understand that we're simply abandoning that former requirement that we kind of focused on in Cisco 1 that said, if devices are connected to the same switch, they're part of the same network. Doesn't have to be that way, right? Okay, so with VLANs, we define our VLANs. So maybe this is VLAN 10, and this might be sales. And I want this guy to be in VLAN 10 as well. Also in sales. Whereas VLAN 50 might be marketing. And the way we do that is we've got to go ahead and first of all configure VLANs by identification. So I've got ID number 10 and 50 here, I just randomly chose. We give them a name. Obviously, you want to be as descriptive as you possibly can. But then we go ahead and we associate the interfaces or ports on the switches or whatever intermediary device this might be. It could be a multi-layer layer 3 switch to be what are called access ports, as opposed to being what are called trunk ports. So on the left-hand side of this switch, these two ports would be defined to be access ports, because that's how we access the bigger picture, right? Remember back in Cisco 1, we learned there were 3 different hierarchical layers in a network infrastructure. The access layer, which is where we kind of reside, end devices, right, and switches. Then the distribution layer, that's where routers are. They distribute traffic between networks. And then the core layer, which is really more your backbone, you get into that if you go on to take Cisco 3, right? So if you can remember that, that'll help you remember, oh yeah, I got to set these switch ports over here to be access ports. So you're not really putting the device itself, PC0 and PC1, in a VLAN. You're putting the access port that they're going to ultimately be plugged into in the VLAN, all right? Same thing here for PC2 and PC3, wherever they're plugged in on this switch, those will be our access ports, right? Switch port mode access. Now, in order to carry that tagged traffic that you should have read about, right? Because when you've got devices that ultimately end up being part of a VLAN, there is a VLAN identifier that gets quote unquote tagged and inserted into the Ethernet frame. That's how the switches can identify where that traffic came from. And we call it IEEE 802.1Q encapsulation for tagging traffic. So it allows for ultimately PC0 and PC2 to be associated with VLAN 10. And their traffic is tagged as originating from virtual LAN number 10, the sales VLAN. Likewise, PC1 and PC3 end devices that are connected to access ports that are associated with VLAN ID number 50, which is the marketing VLAN. So while the left side of this switch and the right side of this switch, we would have to define those ports to be access ports. The switch ports between these two switches would be defined as what are called trunk ports. Because what we've established here, this cable here is my trunk link. And we talk about trunking, we're talking about making sure we can take this tagged VLAN traffic and have it pass between intermediary devices. Now they get into, and you should have read about this, Cisco's proprietary DTP, dynamic trunking protocol for negotiating whether a trunk exists or not. Hey, good to know about, especially if you plan on taking the Cisco exam at some point, because you're going to definitely get a question on it, probably just one. But in practice, if I want this to be a trunk link right here, hey, just manually set the endpoints to be right in the same way that I manually set these other ports to be access ports, right? So, and that kind of goes for a lot of things where there's a negotiation that could happen. The only time, in my opinion, you really want to use any kind of negotiating type of protocol is when you may not have authority over that device you're trying to negotiate with. So maybe you've got separation of administrative control over the network, and you can't set the other end of that trunk link, so you rely upon DTP to establish that trunk. Could be you're working with a vendor, you're working with a supplier, whatever, right? So that's the only time that you'd really want to use some kind of dynamic trunking protocol. Okay. So a few things to note here. So, right, some VLAN benefits, right? Cost effective. I can cut down on the number of devices I need to actually invest in, keep my capital equipment costs down, because you know, I don't necessarily need to dedicate a single layer 2 switch to each physical LAN that I'm supporting. Right? I can make more efficient use of those available ports on those switches. It can make things a lot more manageable, as I mentioned before, right? Better performance, because those broadcast storms don't occur as they would in a traditional non-VLAN type setting. So I can be more efficient with traffic patterns. So those are your main benefits. Now, this is not new. You guys did stuff with VLANs back in Cisco One. Remember that? Right? You only did a very little bit with it, right? There's two things that come to mind when I think about Cisco One when it comes to VLANs. Okay? You actually learn about the switch virtual interface, right? Remember doing that early on in Cisco One, where they said, hey, there's a switch that doesn't need an IP address, and here's a switch that doesn't need an IP address, right? I don't need to assign IP addresses to all 6 of these devices in my illustration here, right? I only have to assign an IP to the end devices, these 4 PCs. And they'll be able to talk to each other perfectly fine. Because if we remember this, a switch is a layer 2 device. It's completely protocol independent. Protocol IP is up at layer 3. The switch, it's above the switch's pay grade to know what's going on at layer 3. If we're talking about a traditional layer 2 switch, right? But we said, you know what? Yeah, the switch doesn't demand an IP address, but at some point in time, I'm going to want to have to manage that switch. And I don't want to have to go through that painful process of going to my data center or my server closet, wherever I have this switch rack mounted, with this ridiculous console cable in hand and wheel a device or bring a laptop in it. I want to be able to manage these switches by going through my network. I don't want to have to physically be there with a blue console cable, right? So we said, yeah, so the argument there is let's set an IP address on this switch. That's you defining a switch virtual interface. Right? You did that. Okay, well, that kind of begs, what are the types of VLANs that exist? Right? And one of them is considered the default VLAN. And by default, that's VLAN 1. That's the one you were using when you set your switch virtual interface. And what you were actually doing is you were setting that default VLAN to be your management VLAN. They didn't want to complicate things back in Cisco 2 and say, okay, here's what a VLAN is, and for security, you should use the non-default, so don't use VLAN 1. They don't want to get into that. We're getting into that now, right? The goal here is for a management VLAN, this is where we're talking about a switch virtual interface. So essentially assigning an IP address to a switch, so you can what? SSH into it, right? Or historically, telnet into it. Okay. Setting up SSH is a different animal altogether, right? But wasn't that the goal? We said the switch doesn't require an IP address, but if I ever want to look at how it's configured or remotely reconfigure it, I better either A, be prepared to physically go to that switch with a console cable, or more likely, give it an IP address, give it a leg to stand on, and I can remote into it with SSH, right? Because that's all Secure Shell is, a remote management protocol. What they're going to have you do in this class is oftentimes, so in Cisco 2, you'll usually use VLAN 99. Okay, they'll have you get in the habit, and they just randomly chose that one for whatever reason, right? As long as you're not using the default VLAN 1, right? We're trying to obscure things a bit from hackers, because they're going to try VLAN 1, hoping that whoever set this up for management purposes didn't know enough to get off of VLAN 1, the default VLAN. Right? Okay, we're spending almost all of our time here though on data VLANs. VLAN 10, which I set for sales, VLAN 50, which I set for marketing, carrying actual data, which is going to be tagged traffic over those trunk links and allowing for devices to talk to each other. They spent a little bit of time getting into voice over IP, and one little blurb on VoIP VLANs, right? They've got to be carried in a separate VLAN. Separate VLAN altogether. They might be hanging off of an end device using ultimately the same port on that layer 2 switch, but they've got to be set with different tagged identities for VLAN purposes. Okay. The main reason for that is because of the quality of service, or QoS. As you'd imagine, voice traffic should take a higher precedent than data traffic, right? We don't get into QoS in this class. You'll get into that if you take Cisco 3. You'll get into it if you take, or when you take the server class and a few other higher level like cyber classes, where you can put a priority on different types of traffic. It could be per person. The CEO gets the highest prioritized traffic, right? Because they demand it, and we do whatever the CEO asks of us. Same with the CFO and CIO and whoever else says we got to give it to them, right? As long as we've agreed on it, right? Or types of traffic, right? General web email traffic, low priority. Phone conversations over a VoIP handset, that's real time. That better have the highest. That better get through, right? So that's the main reason why voice VLANs are separate from data VLANs, because their priority is and always should be higher. Okay, and then one more is legacy purposes. They're called native VLANs, and a native VLAN is just for legacy purposes. So we can carry non-tagged traffic for devices that just don't get it. So think older legacy equipment like a hub that doesn't understand VLANs. Right, so it's a bit of a stretch, but maybe you're working for a nonprofit at some point. They've got some older relic equipment, and you're forced to use a hub that doesn't understand VLANs. You'd have to support that legacy traffic with a native VLAN. It'll carry non-tagged traffic among devices, because the hub can't figure it out. We're going to spend like 99.9% of our time on these guys here, right? Data VLANs. And so this whole VLAN concept isn't really new to you, right? Because you did set up a switch virtual interface for management purposes. And so let's do this. So in Cisco 1, you did this with respect to VLANs. Right, that was one thing. But another thing you guys did, in fact, unfortunately, if you're not here, you guys won't see this, but for those of you that are here in class, look at the Hey You document posted on the wall beneath the big TVs, right? Mark Kraskelski there, getting your attention. Hey You, what is one of the steps there that relates to VLANs that you see? What is it, Jacob? Exactly, yeah. So delete VLAN.dat file, right? Do you guys remember doing that at some point in time back in Cisco 1? So we always say, if you're going to work with physical equipment here in the classroom, switches, routers, whatever, make sure to flatten them when you're done, right? Put them back to their factory defaults. And part of that means erasing startup config. And with respect to layer 2 switches, wiping out the VLAN.dat file. Now, you might recall whenever you guys did that, it always gave you an error saying, well, there is no VLAN.dat file because we never actually set any VLANs, right? The only thing we set was the management default VLAN, which already exists. So I still always encourage you to do it, even if you got an error, because now when we work on the equipment and you actually build these data VLANs for marketing and sales, you'll have to go ahead and delete the VLAN.dat file because that's where all the normal VLANs go to, right, in that file. All right. So we've had a little exposure to VLANs in Cisco 1, but it was really just for management of those layer 2 devices. All right. So back to our packet tracer here, right? So you're going to be doing this in the activities, especially the one that will be due for next week. But we'll be setting the VLAN IDs, naming them accordingly so that we give them a friendly name, right? So we can manage them more sensibly. And I go through and do that, and I set these access ports, and then I set the trunk link by setting the trunk ports here. What I'd be doing here is, even though this looks like one happy network, right? Back in Cisco 1, we would say, hey, that's one network. Now that we have some more information here, specifically that there's a virtual LAN 10 and a virtual LAN 50, we know now that this isn't one network. This is two networks, right? Because we've got to remove ourselves from just looking at it in a physical realm. So at this point, PC0 should then be able to talk to PC2. And PC1 should be able to talk to PC3. Why? Because these switches understand what VLANs are, and they'll be able to carry that tagged traffic in those Ethernet frames to allow for communication between devices that are in the same VLAN. Okay, that's the key here, in the same VLAN. Right now, based upon what we've done, and this is all like chapter 3 stuff. PC0, assuming I went through and configured everything properly with VLANs, PC0 and PC2 should be able to talk to each other. But everything is remaining at layer 2. PC1, PC3 should be able to talk to each other because they're in the same VLAN. But what did we learn back in Cisco 1? If device A on one network wants to talk to device B that lives on a different network, they have to go through what kind of device? A router, right? They have to dabble up into layer 3, our network layer. If you have to. If every device in your home is on network 192.168.1. something, probably, right? And for you to talk to a device out on the internet, you have to go through your router, right? Your default gateway to get there. You have to. No different here with VLANs. Right now, with this illustration, with my demo, PC 0 and 2, the guys up top, they can talk to each other. PC 1 and 3, the guys in the bottom, they can talk amongst themselves, but we can't talk across sales and marketing. Okay? Salespeople can't talk to marketing people as it stands right here, because we're entirely living at layer 2. Okay? These are some of the reasons I'm always pushing you to think about that 7-layer model. If for no other reason, people are gonna refer to a traditional layer 2 switch. You're not confusing that with a layer 3 multi-layer switch. Right? So there are some devices that people refer using the OSI model as a reference. But it also helps to kind of illustrate your understanding of how communication works. And if these are traditional layer 2 switches, and there's no router in my picture, no, we're not talking between sales and marketing at all. Okay. So that is kind of chapter 3 in a nutshell. You'll go through and configure things. And as always, and I've said this before, and if you haven't for Cisco One, I kind of don't care early on if you know how to do something. That sounds kind of crass. But I can't stand it when students embark on doing something and going through the steps when they don't fully understand and appreciate the why. You have to understand why VLANs are important, why they're valuable. If you don't understand that, then who cares if you can configure this and cookie cutter go through the instructions in the lab, right? So hopefully you're feeling okay with why these VLANs are beneficial. Cost, performance, right? Manageability, security. And for no other reason, I can have devices scattered throughout my infrastructure, be part of the same network, and not be required to be connected to the same layer 2 device. All right, that's chapter 3 in a nutshell. Chapter 4, as you see, there it is, right here, is entitled Inter-VLAN Routing. Inter-VLAN routing. I'm a big stickler for getting the lingo down. Inter, as opposed to intra, as opposed to extra, right? And you'll see these terms pop up. So important network terms. Inter, intra, extra. What does inter really mean as a prefix? What do you think inter means as opposed to intra? How are those two different? So if someone's talking to you about an intranet as opposed to an internet, I'm not talking the big internet that we talk about getting to the outside world. How are those different? Anyone know? Yeah, Jacob, what do you think?
Inter can be inside.
Opposite, close.
Intra can be inside.
You got it. Intra as a prefix really means kind of within, right? So the intranet is available only within our organization. Yeah, within, right? So that's intra. Whereas inter is between, or maybe even across the network. Looking at a bigger picture, I need to access another network. Do we have connectivity between these networks? So for example, if you're a baseball fan, the one I always use, Major League Baseball has what they call interleague play. Didn't have it, whatever, 10, 15 years ago. Now they do it. It's great. It's been great for baseball. Right? The Milwaukee Brewers are a National League team, but they occasionally play American League teams. They'll play the Minnesota Twins. They'll play the Chicago White Sox, right? And not just their traditional Cubs and Padres and other National League teams, right? That's called interleague play. You've got teams that are playing kind of across leagues, right? Or between leagues. In keeping with, I guess, our baseball analogy, I always like to say, this is like being part of an intramural softball league. I played a ton of softball leagues, some co-ed, some just guys, especially when I was younger. And intramural means you're playing only the other teams in that particular softball league, right? There might be 8 teams, you're going to play them each 2 or 3 times maybe, right? But that's all within that particular league. Yeah, maybe you go to tournaments and play completely separate teams, but as far as league play is concerned, it's all done within that league, right? And then we look at an extranet, right? And this is outside. So now we're talking about things like your DMZ, right? What we'd often call a screened subnet. That's where you're getting to anytime you order something on Amazon, right? I mean, they're not giving you access to their private network. They've got out in their protected screen subnet, in their demilitarized zone, their extranet, a front-end web server. you're getting to that securely, and then that is more importantly, securely talking to an SQL database server within their environment, right? So that's the extranet, right? The outside network. So it's important to kind of have an understanding of these terms. So back to this guy, inter VLAN routing. That's simply routing between VLANs. And so let's apply chapter 4 here to our network. And there were 3 different ways. Again, if you had read chapter 4, so module 4, right, inter VLAN routing. And they focused on 3 ways you can route between VLANs. First one is what they refer to as legacy, so completely old school. God forbid you ever have to use this, but it helps to kind of illustrate how things used to be done. Okay, so we'll look at that one first. Then we have a really weird named one, router on a stick. This guy uses what we call sub-interfaces. Not as challenging as it first maybe appears. And then the most attractive way, although the most expensive, so depending upon the budget of the organization, they may not be able to warrant going this route, or based on the size of the organization, router on a stick might work perfectly fine for them. But most organizations of any size are going to go with the third option, go with a switch that can also route. It's a layer 3 switch. Okay, so this is really what chapter 4 focused on. Right, let's take a look at legacy old school. Here's how that works. We would have an actual, and again, this is old school, we would have an actual router that we put in place. And we would connect said router to a port on the switch. Now, remember, switches have a lot of interfaces, or they should, because they're ultimately connecting end devices, right? So the port density is going to be pretty high. Routers, as you can see there, not so much, right? Why? Because routers don't connect end devices, they connect what? Entire networks. So we expect to have a limited number of interfaces on a router. That's what plagues the first legacy old school way of making VLAN traffic routable across VLANs. It would work here, yeah. Connect this to gigabit, whatever, and then maybe I connect this switch even, any available port, to the other gigabit port. I've exhausted all interfaces on that router. So this would work just fine. I would configure IP addresses on each of these router interfaces, one that jives with whatever VLAN 10 network is, and the other that jives with whatever VLAN 50's network is. And I would have a routing table in the router. Now, anytime a device in VLAN 10 sales wanted to talk to a device in VLAN 50 marketing, it would always have to go through what? Through our router to get there. The performance really sucks with this. But this is how we did things 30 years ago. It's the only option we had. And VLANs have been around for a long time. But that's why this is legacy, old school. It is severely hampered by a lack of scalability. 2 interfaces, all I have there, all I need, because I only have 2 VLANs. If I throw another VLAN into the picture, right? I put another device off switch 0, another device off switch 1, and I want to add VLAN 80. I better be prepared to add another router into this mix, or expand the interfaces on this router. So that's not a very scalable way of doing things. Okay, so that's the biggest knock on it. Not scalable. Probably never going to see it. Or if you do, it's because it's a ridiculously small environment of just a couple of VLANs. Enter router on a stick. And with router on a stick, we go, okay, let's just have that router connected in this stick capacity to one of my switches. And let's overcome what was a lack of interfaces by defining what I put here, what are called sub-interfaces. They do a real good job of illustrating that when you read up in chapter 4, and those that read this saw this, where I would have a sub-interface of gigabit 000, maybe .10, right? Align it with whatever your VLAN IDs are. And then that same gigabit 000.50, that's the one for marketing. Much more scalable. I can have 2, 3, 4, 5, 15 different VLANs all going through this stick between switch 0 and router 0 and using the appropriate sub interface of that same gig 000. Performance is going to kind of suck if I have that many VLANs because everything's got to go through the stick when we're routing from one VLAN to another. So doable, yeah, not nearly as scalable though, better than the first one, but not nearly as advantageous as a multi-layer switch. This is what most of you are going to see going forward if you're supporting a network infrastructure. You're not going to be dealing with a separate router. There is no router on a stick to contend with. You won't be using traditional layer 2 switches. You'll instead be using a multi-layer switch, which is nothing more than a layer 3 switch. So think a switch that doesn't function only at layer 2, understanding just MAC addresses, but a switch that functions at layer 3, meaning it understands MAC addresses at layer 2, but it also acts as a router at layer 3 that can route between networks, or in our case, between virtual local area networks. That's far more prevalent. Yeah, you'll pay a little more premium for that, but now we get high density multi-layer switches. It's kind of like what you guys have in your home, right? I mean, you technically have a multi-layer switch as your quote unquote router, right? Not a lot of ports in it, probably just 4 LAN ports, right? Or Ethernet ports, however they're labeled on the back of that quote unquote router. But isn't that what you have in your home? A layer 3 switch, a multi-layer switch. It can switch, right? Forward Ethernet frames when it needs to, when all your traffic is within your network, or it can route if you've got to talk outside of your LAN in your home. The wireless access point function of your quote unquote router does the same as the Ethernet switch function does. It just does a wireless, right? But it's keeping all that traffic localized. You have multi-layer switches in your home. We just happen to be lazy and we call them routers. But they switch too. They understand Ethernet frames. They have to. All right. This is what you'll be tasked with configuring going forward, right? But you might come across some, you know, like I said, nonprofits. Maybe you're working at you know, Vinny's or Goodwill or something, right? And they've got some archaic equipment because they can't justify upgrading their network, whatever, right? You might be dealing maybe not as much with legacy, but maybe a router on a stick situation. You have to understand how to work with those sub interfaces. Okay, so that's perfect timing. We're about an hour in. That's all I'm lecturing on today. Let's take a look at what I want you to work on after you get back from break. So go to our week 3 post, and let me set this to be active. See it? So today was all about VLANs, right? VLANs in chapter 3, like what they are, basics on them, and then how do we route between? We have to have a router somewhere to talk across that VLAN environment. So continue working on those activities in 3 and 4. For some of you, read chapters 1 through 4 for the first time. And then homework is going to be this packet tracer activity, right? Configuring layer 3 switching. And you can push that up to Canvas. And then take that first exam. I saw a couple of you took it at least one time, which is great. You get a couple more attempts at that one. I think I even might have bumped the time up even beyond this. Okay. So take advantage of the time I give you in the classroom. Right? I want you guys to put the time in. Right? You've signed up for classes. You shouldn't have set any other appointments or have any other reason to not put the time in between our 12:30 and 4:20 time slot. Right? Commit to doing that. I know it's easy to go, oh, Todd, let's just go, whatever, right? It's adult learning. I'm not going to be a hard ass about it and go, you guys got to stick with those 4:20. do yourself a favor, right? I mean, you paid for this class, you set aside the time, right? Use the time. Hell, you can get stuff done and not have any homework. If you play your cards right. Okay? So take a break, do that stuff, make sure to read modules 5 and 6. And remember, Big Brother always can see how much time and when you're last logged in to Canvas. All right, so we have an idea as to how much work students are doing. All right, keep that in mind. That's not a threat, that's just a problem. Yeah.
Well,